Here we go. Let's get ready to do Polly Pocket tutorial number 4. When we're looking at this first problem, once I move the square, we can see that we've got a lot going on. If I put the rectangle back on, we can see that we have a simple distributing problem, distributing the 3x. Or if I put the rectangle on the first part of the problem, I can see that we have a simple distribution problem where we're distributing the 5x squared. So that's how we're going to conquer this long problem, is we're going to ignore parts of it. And we'll do what it simply asks us to do in the beginning. 3x times 4x squared is 12x cubed. 3x times 2x is 6x squared. We've done that over and over again in this packet. Now we're going to go ahead and lift the rectangle. And we can ignore this side because we've already taken care of it. Oh, the green's going to still be there. All right, see this plus right here? This plus tells me that my 5x squared is positive. So as I'm distributing it, I'm distributing it as a positive 5x squared. So positive 5x squared times 8 is a positive 40x squared, right? And a positive 5x squared times a negative 2x is a negative 10x cubed. All right, that rectangle's kind of getting in my way, isn't it? All right, so now let's look at what we've got. Take that rectangle away. We've distributed both the 3x, we distributed the 5x squared, and now we have this long line of terms, and we're going to see if any of the terms are alike. Well, it turns out we've got a 12x to the third, and we also have a minus 10x cubed. Remember, whatever sign is to the left of a term, that sign belongs to that term. So 12x cubed minus 10x cubed is going to be 2x cubed. Then we also notice that we've got a 6x squared plus a 40x squared. You put those two together and you have a 46x squared. Can we combine these two together? Are x cubes and x squareds the same? Can we combine them? Absolutely not. Just as a reminder, it's fun to remember, of course, 2x cubed, we could think about it as 2 pianos plus 46, I don't know, let's just decide x squared stands for M&Ms. 2 pianos plus 46 M&Ms, it's just simply 2 pianos and 46 M&Ms. You can't combine them together and say 48 piano M&Ms. Doesn't work that way. So since we don't have any like terms, this is our final answer. All right, let's look behind the rectangle at this one. Same concept here. We've got a lot going on, but if we just notice that it's simply a distribution problem, so a distributing problem, and then another distributing problem on that side, and we're just going to combine the terms when we're all done, we can do it. So let's ignore the second part and just distribute the first. So here we go. X times 5x squared is 5x cubed. X times 7x is 7x squared. These two problems are way too close together. I'm going to use this rectangle. Ooh. All right, I'm not going to use this rectangle. All right, now I'm going to notice something. When I move this rectangle away, I have to remember that I'm distributing a negative 4x squared. See that negative? That negative, I know you can look at it as a minus, but it's also a negative. It's interchangeable there. That belongs to the 4x squared. So when I'm distributing, I'm saying negative 4x squared times 2 is a negative 8x squared. And negative 4x squared times negative 3x is a positive 12x cubed. And then when I'm done, I'm looking for terms that are alike. And I notice that I've got a 5x cubed and a 12x cubed. It's kind of the same pattern as the other problem. They don't always end up being the first and the last are like terms. Certainly that's not usually the case, but okay, I don't want you thinking it's always that way. It's not. So we have 5x cubes and we have 12x cubes. So together we have 17x cubes. And then we see that we have 7x squared, and that's positive, minus 8x squared. So if I put 7 minus 8 in my calculator, I would get a negative 1x squared. So I'm just going to write negative x squared. Can I combine these two terms? Are they alike? No, no, no. An x cubed is not like an x squared. They're two different types of terms. They are not like terms. So that is your final answer. The next one says, let's distribute multiple times. All right, these problems to me are a little too close together, but I'll try to write a little smaller. So here, we're used to just having one thing to distribute. And right now, we've got two things. So as I'm looking, let's say I only had the 3x times 7x minus 1, right? I would just go ahead and distribute the 3x. Well, funny thing is, that's how we're going to start this problem. We're going to look at the 3x and ignore the 5, and we're going to distribute the 3x. We'll say 3x times 7x is 21x squared. 3x times negative 1 is negative 3x. And we're done, right? We distributed the 3x. But wait a minute. The 3x has company. The 5 is also part of the distribution process. So we are done distributing the 3x, but now we have to do the same thing and distribute the 5 to the polynomial, which has two terms, which we talked about. It's a binomial. So we've got to distribute the 5. So I'll do the under swinging lines or curves to show that I'm distributing again, but this time with the 5. 5 times 7x is 35x. And 5 times negative 1 is negative 5. I just made it so that the other didn't write into the rectangle. Okay, do we have like terms? Do we ever? Negative 3x and 35x are like terms. The other two are not. So we're going to go ahead and combine negative 3x plus 35x is going to be a positive 32x. Then we have a minus 5. So what did we just do? Basically, what we're doing, especially in this packet, we're learning the rules about what's allowed skill-wise as we do layered problems in the future. So this packet is helping us to build skills like this, where we're distributing twice. We're multiplying a binomial, 3x plus 5, times another binomial, 7x minus 1. And this is the way we do it. So we're going to practice it, because practice really does make perfect, especially if you can figure out how to practice perfectly. All right, so that's one problem, and I'm going to try to physically block that so we're not looking at it anymore. We've got the same thing, a binomial, 2x plus 3, so it's a polynomial with two terms, so a binomial, times, see how there's the two parentheses are right next to each other? That means times another binomial. And once again, we're going to start with distributing the 2x first to the second binomial. And we're used to that, so here we go. Let's distribute the 2x. 2x times 5x is 10x squared. 2x times negative 4 is negative 8x. Then we're going to distribute the 3 to the second binomial as well. It's the 3's turn. So here we go. Let's switch back to the blue. 3 times 5x is a 15x. And 3 times negative 4 is negative 12. The way these are set up, both binomials have the first term is the x term and the second term is just the plain number with no variable. We're always going to find that our two inner terms can combine, that they're going to be like terms. So while we can't do anything with the 10x squared, we can combine negative 8x plus 15x to get a positive 7x. And then we bring down our negative 12. So while these problems, as we're doing them, we don't end up with a great answer like 100 or 24. Once again, we're just learning some skills that are going to help us as we become greater and greater mathematicians taking greater and greater math classes. All right, so let's do one last one, because the more practice, the better, right? All right, let's look at this one. Once again, we have two things to distribute. We have the x to distribute and the -9. So here we go. Let's distribute the x first. X times 2x is 2x squared. X times -5 is -5x. Hear how I said that was a -5? Because to the left of 5 was that minus sign. And when we say, well, what is 5? 5 is really a -5. I know that bothers some people, but just got to get used to that. Then, see, this isn't a 9. This is a -9 right here. So I'm going to distribute the -9. -9 times 2x is -18x. -9 times -5 is a +45. I know I'm doing these in my head, but please use your calculator. If you're a little rusty on your multiplication facts, use your calculator. All right, so we're going to bring down the 2x squared, but we're going to notice like terms in the middle, just like in the first two problems. -15x minus 18x, you can go ahead and put that in your calculator and get a -23x. Of course, you can't put the x in the calculator, but if you put -5 minus 18, you'll get that -23. And there we go. So when we're asked to multiply a binomial times a binomial, this is what we're going to get. We actually, in this case, get a trinomial. All right, I think that's it. This was a very fast tutorial. If I hadn't made so many commentaries, it would have even been faster. So go, go, go. Keep going on your packet. You're doing great. See you next time.